So this begins part 2 of our video series on graphical representations. So we're going to look at different types of linear equations, how we can graph those, looking at different statistical models, mean, median, mode, and then look at some probability types of situations. So here's our, as you can see, our objectives. So we're going to begin that idea of graphing in two variables, slope, intercept, and standard form. Definitely hitting on the foundational pieces of that. You'll also see that again in your next course in much more detail. And then we're going to look at finding the mean, median, and mode of a set of numbers, and then different application problems that involve that. And then we're going to look at different probabilities of events. So to get started, when we look at trying to graph each of these on graph paper, so if I ask you to do that, of course, I will give you the graph paper to plot your equation. Now, all of these have an x and a y, and they have a constant. Now, if you look at A, B, and C, they're all in a similar format. So I have a slide for each of these. So I'm going to take x plus y equals 6. And what I want you to think about is solve for y. We want to put it in a form called slope-intercept form. And this is one way we can do that, okay? With x plus y equals 6, if I solve that for y, I'm just going to subtract 6 to both sides, okay? So that's going to give me y equals negative x plus 6. From there, I'm going to start and I'm going to plot my y-intercept, which is positive 6. So 1, 2, 3, 4, 5. There's 6. And notice my slope is negative 1. So it'll be negative 1 to the down 1 to the right 1, down 1, right 1, down 1, right 1, over and over and over. And then you have your line to plot. Now that's if you worked towards the equation y equals mx plus b. We also have a form called standard form. So ax plus by equals c. And if you're in that form, which is part A, is in that form, to find intercepts, you could substitute a 0 for y and solve for x, which would make x equal 6, which we notice 1, 2, 3, 4, 5. There's your x-intercept. And then we could do the same for y, as we put a 0, substitute a 0 for x, and solve for y. So y is equal to 6, which is what we see here. So a way to, if possible, and it divides nicely, we can figure out our x and y intercepts from standard form. That's one method. The other method is to take the equation given, solve it for y, so you find your slope and your y-intercept. So the second one, let's look at part B. X plus y equal 4. Let's go ahead and solve it for y. So let's subtract x on both sides. We get y is equal to negative x plus 4. So I'm going to go up 4 on the y-axis, 1, 2, 3, 4. I'm going to put my point there, which represents my y-intercept. And then I'm going to plot my slope, which is a negative 1, down 1 to the right 1. Or we can think from the intercept, up 1, left 1. And we create our line. Notice we have our intercepts. And also notice that x plus y equal 4 is in standard form. So if I want to find the x-intercept, I just substitute y for 0, so that becomes x equal 4, which we see is here. And if I want to find my y-intercept, I substitute a 0 for x and make it y equal 4. And if you were to graph it using intercepts, you would just plot the two intercepts and draw the line between them. Part C is not quite in that form. It is in the form mx plus b equals y, which is the same as y equals mx plus b. The y can be on the left or the y can be on the right. It doesn't matter. So when we have x minus 2 equals y, this minus 2 represents the intercept. So I'm going to come 2 units below 0. You're always thinking you're starting at 0 and I'm moving 2 units below. But then notice that slope. That slope is an understood 1. So that means it's understood up 1, right 1, up 1, right 1, up 1. Notice that I'm creating that fraction, up 1, right 1, which is also your rise divided by your run. And so we should see points fall in the line. And we'll notice our y-intercept and our x-intercept. So if we wanted to change this x minus 2 equals y into standard form, I would like to keep my x coefficient positive. So I'm going to add 2 and subtract y. So x minus y is equal to 2. So I just added 2 to one side and subtracted y to the other side. So you get this form here. So if I want to find my x-intercept, I substitute an x, 0 for x, and now I have negative y is equal to 2. So that means positive y is equal to negative 2, and that's what we had originally. And then if I have x minus y is equal to 2, and I substitute a 0 for y, I'm going to have x equal 2. And notice that's where it crossed on the x-axis. Looking at part D and E, they are already both in the y equals mx plus b format. So I'm just going to go ahead and go to negative 5. 1, 2, 3, 4, 5 below 0, and that's a slope of 1. So I know that's going to be rise 1, run 1, up 1, right 1, up 1, right 1. And that would be my line. You'll notice there's my y-intercept and there's my x-intercept. And then part E, I'm going to go to positive 3, so 3 above 0, 1, 2, 3. Now that slope is 2, which means it's 2 to 1. So that means increase 2 to the right 1, increase 2 to the right 1, or decrease 2 to the left 1, decrease 2 to the left 1. And there is my y-intercept. And my x-intercept, you notice, is going to be some sort of fractional amount. It falls in between two numbers. But if I wanted to, let's take part E and let's make it into the ax plus by equals c. So I've got y equals 2x plus 3. I'm going to subtract the 2x from both sides. So I'm going to rewrite it as negative 2x plus y. As a matter of fact, I'm going to just I'm going to leave the x coefficient positive. So I'm going to subtract, I'm going to subtract 3. So I have y minus 3 equals 2x, and then I'm going to subtract y. You might be thinking, well, why did he do that? Why did he move the y? Because typically by definition with the standard form is a and b are integers and a is a positive integer. So that allowed me to keep the a positive. And so if I wanted to find my x-intercept, I would have negative 3 equals 2x because I just made y 0. And when I divide by 2, I'm going to get negative 1.5. And that's about where it is. It's about right there, negative 1.5 in yellow. And then, of course, if you want to find your y-intercept, negative 3 equals substitute 0 for x. You get negative 3 is equal to negative y. That means positive y is equal to 3. And, of course, that's what we found already. So these are examples of where if it is in standard form, you could look at using the x-intercept method, or you can solve it for y. But when you do solve it for y, go ahead and plot your y-intercept first, and then apply your slope to your y-intercept. Here's another set of problems where the slope is fractional and everything is in the format of y equals mx plus b. So let's start with A. Notice there is nothing out here that you see. There's nothing, there's no add anything or subtract anything. So that means it's understood that the y-intercept is 0. Because if it's 0 out there, if I add 0 to 1/3 x, I don't change the problem. So just, I can have plus 0, or you can have nothing out there. It means the same thing. So now we want to apply our slope from the y-intercept of 0, which means we are going to rise 1 on the y and run to the right 3 on the x. So up 1, 1, 2, 3, up 1, 1, 2, 3, or from the origin, come down 1 and left 3, down 1 and left 3. And then I just want to plot these points. And then you see your graph is a little less steep than maybe some of the other graphs we looked at earlier, right? Just doing some comparisons. It's not as steep, right? Well, there's a reason for that, because the slope was a fraction. Let's look at part B. I'm going to plot -3. So come down from 0, 1, 2, 3, plot my y-intercept. And now I'm looking at my slope. Notice that's a -2 in the numerator and a +3 in the denominator, which means from my y-intercept, I'm going to actually move down 2 to the right 3. 1, 2, 3. Down 2 to the right 3. Or from the -3 y-intercept, I could go up 2 to the left 3. Up 2 to the left 3. Notice what I'm creating is I'm really creating these slope triangles. So the slope is negative. Look at part C. I'm going to plot the intercept at 4. 1, 2, 3. It's a +4. And from there, I'm going to rise 3 and go to the right 4. So 1, 2, 3, 1, 2, 3, 4. Or I can go down 3. See, down 3 and left 4 is the same as up 3 and right 4. Because what's a negative divided by negative? Well, that's a positive. So 3/4 is equal to 3/4. So I can go down 3 to the left 4, 1, 2, 3, 4, and it still be on the same line. So you can see your slope triangle of 1, 2, up 3, 1, 2, 3 to the right 4, 1, 2, up 3 to the 1, 2, 3 to the right 4. And then D, I'm going to go to 2 on the y-intercept, and then I'm going to apply my slope. So I'm going to go up 2, right 1, 2, 3, 4, 5, or I can go down 2 to the left 5, 1, 2, 3, 4, 5, and just plot those 3. And then we've got different examples where we've got horizontal lines and vertical lines. So far we've looked at equations that lean this way or that lean this way. And now we're going to look at equations that are horizontal or vertical. So in this case, we've got y equals 2. Well, what we're saying is this line is going to cross the y-axis at 2. And this is all you have to do there, is draw that line that represents 2 on the y-axis. What about y equals -4? We'll go down on the y-axis, 1, 2, 3, down to -4, and draw your horizontal line. That horizontal line is what's going to intercept the y-axis, because it's going to intercept at -4. What about y equal 3? Well, I'm going to go up to 3, above 0, and draw my horizontal line. And then finally, y equals -1. We're going to come down to -1 here and draw the line that goes through the y-intercept, -1. So some things to think about here. You see the y equal. You're thinking the y-axis, it has to cross through the y-axis. Where? At the number that it tells you. 2 above 0, -4 below 0, 3 above 0, or -1. Then you've got a set of examples where you see everything is x equal. Well, that means that we're going to intersect the x-axis. Where? At the point given. So x equal 2. So we're going to come to the right 2 of 0, and we're going to plot this line. And it is a vertical line that crosses the x-axis at the given value. X equal -4. Go to the left 4, plot the x-intercept, draw your line. X equal 3, go 3 to the right of 0, plot my x-intercept, draw my vertical line. Finally, go to x equal -1, which is over here to the left of 0, 1 unit. It is an x-intercept, so it's going to have a vertical line that crosses the x-axis at -1. So those are your examples of looking at horizontal lines and vertical lines, as well as given equations that are in slope-intercept form or standard form. Next group, we're going to look at the mean, median, and mode of a set of numbers. So if I say 4 days on a trip, a car was driven, so it drove 240, 302, 280, and 320. What you're going to do is you're going to find the sum of that. And when it asks for the mean number, mean representing average, that's just another word, of course, to represent for average. Mean represents average. Mode represents the number that was representing the most often in a set of data. And your median is your middle number that is in a set of data. So in this case, we're just going to add all these up. 10, 14, so 2, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 1,142. And how many numbers did we have? We had 4 days, right? So 4 numbers. So we're just going to divide by 4 to figure out what the mean number of miles per day. So I'm looking at 11 hundreds, and so that's going to be 200. So 11 hundreds take away 8 hundreds would be 3 hundreds. Bring down my 4. So now I'm dealing with tens, 34 tens. And so my answer is going to be up here in the quotient in the 10 spot. So 8 tens, 8 times 4 is 32. 34 tens, take away 32 tens would be 2 tens with 2 ones. 4 will divide 22 5 times. So notice if I continued, 4 would divide 20, so 5/10 times, sorry, that would be 5/10 times. So 285 and 5/10, or 285 and 1/2 miles per day. So that's finding the average, where you're going to take the sum and divide by the number that are given. So if you're going to get an A, Alex must score a mean of 90 degree on 4 tests. So on the first 3 tests, what does she have? She has an 80, she has 100, which has 86. We don't know what the next test is, but Alex is going to take 4 tests. So if we knew what those numbers were, wouldn't you add them up and divide by 4? Yeah. Well, if you want a mean score of 90, then you know you want it to be exactly 90. So that average needs to be 90. Well, okay, so I want to solve for x. Well, I'm dividing by 4 here, so I want to do the inverse of dividing by 4 is multiply by 4. So that will eliminate the 2 4s here. And then that's going to give us 80, and 86 is 166 plus 100 is 266 plus x is equal to, what's 90 times 4? That would be 360. And so if you have 360, if we take away 266 from it, Alex needs to score a 94 on the last test to still get an A, while scoring an 80, 100, and 86. That 4th test has to be a 94. Now, what if Alex wants to get a B? So now we've got 80 plus 86 plus 100 plus I don't know, but we would divide by 4, and we're saying to get an 80, we have to set it equal to 80. Well, we already know what these are going to equal, right? That's going to equal 266. So that's 266 plus x is equal to, because we've already multiplied both sides by 4, so that would equal 320. So let's take away 266 from both sides, and basically Alex needs to get a 54 on the 4th exam to maintain a B in the class. So that would be, the last 2 are about trying to find averages and dealing with averages. If we were looking for the mean on this, we would add up all the numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We would find the sum and divide by 12 to find the mean. Now, if we were looking for the median, what we're looking at is just the middle number. Now, you always want to check, but what you want to do is put the numbers in order. And for the sake of the time and the sake of our class time, I did put them in order. Okay? So what we're looking at is we're trying to figure out what is the middle number. Well, we already know that there's 12 of them. So that means you're going to have 6 on either side. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So your median is actually going to be somewhere in between. It will be 36 and 1/2. It's the middle number between 36 and 37. That would be the median. Now, if we think about, all right, well, what's the mode? The mode is the number that's going to represent multiple times. Well, we see 34 3 times. We see 37 3 times. So we can actually have co-modes, or sometimes we can say bimodal, if I spell that correctly. We can have and so in this case, the modes would be 34 and 37. The modes are just the numbers that represent and that show up most often. The following are salaries. So what we're looking at is the median salary. So we would need to put these salaries in order, and I'm missing a 0 right there. So I need to put in a 0 there. Apologize for that. So we have 8,700,000. And then we have 8 million, and I missed that one, I'm sorry. This is your lowest, and then 2, and then 3, and then 4. So we've got 8,250,000, and then we have 2 at 8,700,000. These are not teacher salaries, I can assure you that. So this is 9,500,000. So when you're looking for the median, you see you have 4 numbers here. Well, it's the one in the middle. Well, there's not really one in the middle, right? So we would say, since these are actually the same, we would say that 8,700,000 would be the median salary. All right, so that will conclude finding averages, finding medians, finding modes. And then finally, we want to look at calculating the probability of an event occurring. Probability, by definition, is just the number of ways an event can occur out of the possible. Okay, so if you're thinking about rolling, if you roll a die, and so when you're thinking about rolling a die there, what are your possible events? Well, you only have 6 possible, right? What's the possibility of rolling a 1? Well, only 1 chance, so it's 1 out of 6. Rolling a 2, well, it's just 1 out of 6. So everything, each of the sides on a die would equal 1/6 each time, okay? So this would be rolling a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So when a die is rolled and we say, well, find the probability that a 3 is rolled. Well, a lot of times where we're going to see that is the probability of, we'll see P of 3, or roll we may see the wording there, probability of rolling a 3, and so that would be 1 out of 6. What if we say, well, what's the probability of getting an odd number on a die? Well, now you got to think about all of your possibilities, right? You got 6 possibilities. Well, 1, 3, and 5 are your odd numbers. So that means there's still 6 options, right? But 1, 3, and 5 are the what? They are the number of ways an event can occur, and that would be odd. So that would be 3/6 or 1/2. And that would be the same for even numbers as well, right? If you wanted an even number, probability of rolling an even number would be the same. It would be 1/2. When you're dealing with a deck of cards, finding the probability, well, 52 cards is your total. 52 cards in a deck is your total. So when we wanted to find the probability of a jack, well, remember you've got your 4 different suits, okay, and in each of the different suits, you have 1 jack in each of them. So what does that mean? That means you have 4 jacks out of the 52 cards. And 52 is an even number, so we know it's divisible by 2, and we know 4 is divisible by 2. So we can simplify this into 2/13. Find the probability that a red 10 is selected. Okay, well, we still are out of 52, right? But remember, with the deck of cards, you've got 4 suits. 2 suits are red, 2 suits are black. Okay, well, that means you've got a 10 here and you've got a 10 here. So you actually have 2 10s out of the 52, which would be 1/13. You have 1/13 of a chance that a red 10 is going to be selected. 2 out of 52 or 1/13. Part C says find the probability that a black picture card is selected. Okay, well, we would write that as probability of black picture. Okay, now what that means is you have a king, queen, and a jack, and you have that in each of your suits. You have a king, queen, jack, king, queen, jack, king, queen, jack. So a picture card, remember 2 of the suits are going to be black. So you actually have 3, you have 6 out of the 52 cards, which would be a black picture card. And then 6 out of 52, well, both of them can be divided by 2, remember? So you actually have a 3 out of 13 chance to get a black picture card. And then finally, it says find the probability that an 8 or a 6 is selected. Okay, find the probability that an 8 or 6 is selected. Now, we didn't say colors. Well, remember, we've got 4 suits, right? And in this suit, we have an 8 and a 6. This one, we have an 8 and a 6. This one, we have an 8 and a 6. This one, we have an 8 and a 6. So we actually have 2. So that's why we would add those together. That would give us 2 cards here, 2 here, 2 here, 2 here. So an 8 or a 6 is 2, 4, 6. We have 8 possibilities out of 52. So the probability of getting an 8 or a 6, we weren't specified on the color, would be 8 out of 52 or 2 out of 13. Because 52 divided by 4 is 13, and 8, so what I did was just split it up into 4 times 2 and 4 times 13, because 4 times 13 is 52, so those divide out, so you're left with 2/13. You have 2/13 of a chance to get an 8 or a 6. And then finally, a situation here where we say we have a box of candy, and we're looking at the number of gumdrops. So we've got strawberry, lime, lemon, grape, orange, and cherry, and notice the number in each of those. And so now we can just kind of look at different probabilities. So what if I said the probability of orange or cherry? Well, orange or cherry, that would be 9 plus 4. When you're dealing with this or this, you're going to add those probabilities together, but also need to find the total. So that's 7 and 5, that's 12. 12 and 8 is 20. And then 4 and 6 is 10, so that's 30. So I've got 39. So that would be 13 out of 39. And 39 is divisible by 13, so that would be 1/3. So 1/3 would be the probability of orange or cherry. What if we wanted to say, what's the probability of not getting a, we'll say a lemon? Well, if there's 39 total, if we take 39 and subtract the 8 from it, that gives us 31 possible. So if we don't want to get a lemon, then we've got 31 out of 39 chance of not getting a lemon. If we want to get a lemon, then we know that we've got an 8 out of 39 chance. So if you'll notice the 31 plus the 8 both add to 39. So when you're thinking about, it also is called complements, okay? So when you're thinking about 31 out of 39 and 8 out of 39, well, probability of not getting a lemon is 31. The probability of getting a lemon is 8. Those two had to add together to give you the total. So let's do the same with, let's say, lime, okay? So probability of getting a lime. Well, there's 39 total, and lime was what, 5, okay? So the probability of getting a lime was 5. 5 out of 39, I cannot simplify that anymore. 5 is prime. 39 is not prime, but 5 would not divide 39. So what if we said probability of not getting a lemon? Well, what's 39 take away 5? That would be 34. So 34 out of 39 would be the complement. So those are different ways that we can use probability. And mostly the questions that I'm going to ask you is just determining what the total would be. And then you'll see the probability notation of, I will ask you questions. And you'll notice that it will be in that notation for you to determine what that fraction amount would be. So that concludes our part 2 video, where just a recap, going back to the objectives, is that we looked at equations in 2 variables. We looked at slope, intercept, standard form. We looked at vertical lines, horizontal lines. We looked at mean, median, and mode, different applications, and then we looked at probability of different events. So that concludes part 2 of this video series with graphical representations.